Today we're continuing with our geometry basics and we're looking at how to find the midpoint and distance of a line segment. This can be tricky when we're dealing with a line segment that's on the diagonal. So we'll take a look. What is a midpoint? A midpoint divides a segment into two congruent parts. It could be a point, so here we have point M, and we know this is a midpoint because of these little hash marks that are indicated on our line. These hash marks show that this segment is congruent to this segment. That's what those little hash marks mean. Those two pieces are congruent to each other. That means M is right in the center of segment A and B. A segment bisector could be a point like we have here. It could be a ray, or it could be a line or a line segment. It intersects the segment at its middle point or midpoint. It bisects. Bisect means to cut into two equal parts. So here we have that same segment AB, and we have a line DC that is the segment bisector. It's going right through the segment at its midpoint. Point M is the midpoint of line segment VW. Find the length of VM. This is what we want to find, the length of VM. If we know that this is the midpoint, then we know that this segment is congruent to this segment. Therefore, when we set our equation up, we can set those two expressions equal to each other. And then we're solving a multi-step equation. I like to move my smaller variables to the other side of the equal sign to combine like terms. And then move my constants. And we'll get an x value of 4. We want to find the length of VM. So I'm going to take my 4 and plug it into my expression up here. My expression was 4, plug in 4 minus 1. I'm plugging it into this expression. And we'll get 16 minus 1, which is 15. 15 is equal to the length of VM. It's also consequently the length of M to W, and therefore our whole segment is 30 in length. You try. Go ahead and pause and see if you can figure out PQ. We want to find the length of PQ. We're told that there is a segment bisector. In our first example, ray MN is our segment bisector. If P to M is 3, then M to Q is also 3. Therefore, PQ has a length of 6. In our second example, line L is our segment bisector because it's bisecting it right at that midpoint. Therefore, the expression 5x minus 7 is equal to 11 plus 2x. And we have to solve this multi-step equation by subtracting 2x from both sides. And we'll add 7 and solve a one-step equation by dividing by 3. We get our x value to be 6. It's asking for the length of P to Q, so I'm going to take my 6 and I'm going to plug it into one of the two expressions. So I'm going to go ahead and plug it into this one. We'll get 5, plug in 6 minus 7. We should get 23 for this length. If that's 23, then this segment is also 23. Therefore, the whole length should be 46. You can also find this midpoint of segments that are on the coordinate plane by using the ordered pairs. We'll be finding the average of the x values and the average of the y values, and those averages will equal the midpoint of our segments. So for example, 4 plus 1 is 5. 5 divided by 2 is going to give me this midpoint, so I have 5 halves. 2 plus -3 is -1. -1 divided by 2 is -1/2. That's the ordered pair that will be the midpoint for that. The midpoint formula, you can see how it's derived. Again, we take the average of the x's, the average of the y's, and that's going to give us that midpoint. The midpoint of JK is 2, 1. One endpoint is 1, 4. So there's some important details here. We've got a midpoint and we have an endpoint. Find the coordinates of the other endpoint of K. So we're going to go ahead and plot J first. It's up 1, over 1, up 4. This is J. And we can plot M, which is the midpoint. It's over 2, up 1. Since I have my graph and I know a few things about slope, I can use my slope to count the rise and run in order to get to the next point on my line. So my rise is a -3 over 1. So I'm going to continue to do that, go down 1, 2, 3, and over 1. And this will be the other endpoint of my line. This is going to be the value of K. And K has the ordered pair of 1, 2, 3, 3, -2. If I can plot it on a coordinate plane, using the slope will get me to that next point, and therefore I have found the midpoint and the endpoint. If I don't have the coordinate plane, then I need to do some algebra to figure that out. So go ahead and pause the video and you try on your own. Find AM. So I'm going to set my two expressions equal to each other and solve. If I want to find the length of AM, AM equals 10. Find the midpoint given the coordinates endpoint. If I want to find the midpoint, I need to take the average of the x values, and I need to take the average of the y values. 3 plus 7 is 10. 10 divided by 2 is 5. 5 plus 5 is 10. Divided by 2 is also 5. 5, 5 is the midpoint for these two coordinates. Find the midpoint given the coordinates and endpoints. So I have -7. It's not even on here. And -5, which would be down here. And K, -3, up 7, which is up here. Okay, so it doesn't quite fit on my graph, so it's going to make it hard to find the slope. So I'm going to do my algebra again. I'm going to say -7 plus a -3 divided by 2. And I'm going to do the y values as well. -5 plus 7 divided by 2. -7 divided by -3 plus -3 is -10. Divided by 2 is going to give me -5. -5 plus 7 is a +2. Divided by 2 is going to give me 1. So my midpoint is over here at -5, 1. That's my midpoint. Next one says find the endpoint S given an endpoint of R and a midpoint. So my endpoint is over 5, up 1. My midpoint is 1, up 4. And I have to find, so this is R. This is my midpoint. So I have to find the other endpoint. So it's going to be somewhere over here. So I'm going to show this algebraically. I have, let's see, my other endpoint is S. And S, we don't know the x value and we don't know the y value of that endpoint. So we're going to still use our average formula to figure this out. I know 5 I just don't know s's x value, so I'm going to use x for that. When I divide it by 2, I know that it has to equal the 1 from my midpoint. So I'm ending up solving an equation here. Same thing with the y value. I know one y value is 1. I don't know the other endpoint. I do know that I have to divide it by 2, and it will equal 4. Algebraically, when we solve this, I'm going to multiply on both sides by 2. And we'll get 5x. I'm sorry, we get 5 plus x equals 2. And I'm going to subtract 5 on both sides, and we'll get an x value of negative 3. When I solve down here, I'm going to multiply again by 2 on both sides. We'll get 1 plus y equals 8. Subtract 1 on both sides. We'll get y equals positive 7. So the other ordered pair should be, for s, should be negative 3 and a positive 7. So negative 3 and a positive 7. It's up here somewhere. That looks to be about right. If I want to find the distance of lines on a coordinate plane, it's not that hard if it's horizontal or vertical. If I have 2 points, and we did an example like this in our last lesson, I can just count the distance between those 2 points. 1, 2, 3. That has a distance of 3. If it's vertical, counting the distance, 1, 2, 3, 4. But if it's not, then I need to use what's called the distance formula. And the distance formula comes from the Pythagorean theorem. If I have this point and this point, I'm taking the horizontal distance and squaring it, plus the vertical distance and squaring it, and that will give me the length of that diagonal distance squared. Comes from the Pythagorean theorem, and we'll use that a lot when we get to our triangles. So let's see if we can figure this one out. Let's find the length of RS. Here it is. I've got my ordered pairs. We want to write down our first ordered pair. I'm going to say it's R, so that's 2, 2, 3. And then our second ordered pair, I'm going to say is S. That's 4 and negative 1. We're going to find the difference of our x values. So this one's different. It's not the average where we add. We're finding the difference of our x values. Our x values were 4 and 2. So when I find the difference of that, it's 2. I'm going to find the difference of our y's, negative 1 minus 3. That distance, or that difference, is negative 4. So we've already done this subtraction, and we've done this subtraction. Now we just have to plug it in for our distance formula. So the distance formula is the big old square root of the difference of the x's, which in this case was 2, squared, plus the difference of our y values, negative 4, squared. As we continue working, we work under the radical. 2 times 2 is 4, plus negative 4 squared. Negative 4 times negative 4 is a positive 16. Then we're going to go ahead and add those two values together, and we should get the square root of 20. Now in our algebra class, we learned how to simplify radicals. So if you simplify this radical, we know it's 4 times 5 to get 20. 4 is a perfect square. The square root of 4 is 2. That's outside the radical. And the 5 is a prime number that stays inside the radical. The answer to this for distance is 2 radical 5. You try these two. Pause the video and try for yourself. Find the length of the segments with the endpoints P is 1, 2 and Q 5, 4. So again, we're going to take our difference of the x's and square them, plus the difference of our y values and square them. So I'm going to use P and Q. So 5 minus 1 is the difference of my x's. 4 minus 2 is the difference of my y's. 5 minus 1 is 4. 4 minus 2 is 2. 4 squared is 16. 2 squared is 4. When I sum them up, I get 20 under the radical. And we know from our last example, we have to simplify that to be 2 radical 5. Find the length of the segments with endpoints s is -1, 2, and t is 3, -2. So again, we've got a big old radical. We're going to take the difference of our x values and square them, plus the difference of our y values and square them. S, then t. So I'm going to start with a second ordered pair, so 3 minus a -1, and then -2 minus 2. I want to be careful with any double negatives. 3 minus 1, 3 minus a -1 is a +4. -2 minus 2 is a -4. 4 squared is 16. -4 squared is also 16. 16 plus 16 is 32. So we need to simplify that in some way. Well, we know that we can break this up into 16 times 2. The square root of 16 is 4, and we leave prime number 2 under the radical. 4 radical 2.